All right, so this is your chance to raise your progress learning grade with a 1.10 checkpoint. You do have to show your work on the problems in Classkick, so make sure that you write on the slides, and then you'll need to email me when it's ready to be checked. All right, so this one we need to change all of those in the same format. So you need to make sure you have your calculator. Sorry, my calculator needs to be moved. So we have 1.1448. That's a decimal. Then you're going to do the square root of 2. So use your calculator, and it comes out to 1.4142. So let me just line these up. And the other one was I'll just put 414. All right, it's 14 over 10. You have, you can do 14 divided by 10 on your calculator. Is the easiest way. So just go ahead and do that. Make sure you understand how to change that to a decimal. And you should get 1.4. Now what I'm going to do is just put zeros at the end so they all line up. Same place, number of place value. And then 1.2 squared. So just put 1.2 on your calculator, square it. That one comes out to 1.44. And again, I'm going to put a 0 there at the end to line them all up. All right, so then we have to put the numbers in order from smallest to largest. So if you look at them all, they all start with 1. 10th place is all 4. Now we're looking for the smallest one. So here's 4, 1, 0, 40. Or you can just look at them as like this is 400, or 414, 440, 448. So 400 is the smallest. So remember that was this one. So that's our smallest one. So we're going to eliminate B and D based on that. So this is our first one that's listed. And then the next smallest one is this one, because you have the 414, and this is 440, and this is 448. So this one, remember, was the square root of 2. So this is our second one. So square root of 2 has to be C. So make sure you do show the work on the slide. All right, so this one, which is equivalent to 4.321 times 10 to the negative 4th power, start with a 4.321. This negative exponent tells you to move this decimal to the left 4 times. So there's 1. Then I need to put 3 more places. 2, 3, 4. So here's your decimal now. So you'll need to put in those 3 zeros. So just check. This one has 3 zeros there, so it's going to be A. All right, this one, you got to use the calculator again. So we're going to do the square root of 17 and see which one is the correct place on the number line. So use your calculator, and it comes out to approximately 4.12. Get this back bigger. Okay, 4.12. So you've got this, A is definitely not it. E, here's 4, so it's got to be D. Just check your answer there. All right, this one, it says the subsets of the real numbers can be represented in a Venn diagram as shown. To which subset of real numbers does 12 belong? All right, so 12 is a whole number. So it's inside this, so it's also an integer rational. So that's all those things. So we're going to look for the rationals, integers, whole numbers. Sorry, it's A. Our B and C are missing one, and then this D says irrational. It's not an irrational number. So on this one, it says you have four triangles shown. Based on these triangles, which statement is true? So look at this first part, W equals. We had one like this in class. So if you look at the four triangles, there's only one that has this W. And remember when we had the exterior angle lesson? This is going to be equal to these two added together. All right, so if I add those two together, I get 105. Looks like they've done it a little bit differently, so let's, oh, well, so you can look, this says 175, 110, 70. Oh, I did. All right, Miss Horton, this is supposed to be 65. Sorry, 110. You're like, All right, so rewrite that, 65. I don't know why I wrote 60. 65 plus 45 equals 110. So let's try that again. Look at C. That's the only one that says W is equal to 110. Next one, it says given the lines that A and B are parallel, so these two lines are parallel, this is our transversal, and at the measure of angle 6 is 74. It says to find the measure of angle 1. All right, so you know, or you should know, corresponding angles, that this 2 is also 74. So you have to kind of use all the things about angles. Now, the other thing you should know, this is a straight line here, and those two together will add up to 180. So if you do 180 minus the 74, it's 106. So this is 106. That's just one of the ways to do it. The other thing you could have done is said, well, this is 106, and that's the same as 1. Different ways. All right, we have the Pythagorean theorem. All right, so it says, apply the Pythagorean theorem. A 10-foot ladder is placed against the wall of a brick. Ooh, hold on. There we go. All right, so the bottom of the ladder is 8 feet from the base. So it's this one right here we're looking at. How high up the wall does the ladder reach? So we're looking for this. So we're going to use the Pythagorean theorem. Here's our right angle. So this is C, because so the hypotenuse is always across from that right angle. All right, doesn't matter if 8 is A or B. I'm just going to put it in as B. It doesn't really matter. And this is 10 squared. So then we have 8 squared is 64. 10 squared is 100. We need to isolate that variable, so we're going to subtract the 64. And then we get A squared is equal to 36. And to find A, we have to do the square root of 36, which is 6. This is A. The next one, how much further up the wall does the ladder figure 2 reach than the ladder in figure 1? So again, you're going to have to do the Pythagorean theorem, but then you got one extra step. So this time we have, we can do 4 squared, doesn't matter, plus B squared is equal to 10 squared. 6, that's 16. Then you're going to isolate that variable, so subtract 16. And then B squared is equal to 84. And you have to do the square root of 84. Let me get my calculator again. Should have had my graphing calculator handy. So I'm going to do 84 square root, and it's going to be approximately 9.17. if you round it. So the question that we're trying to answer is how much further up the wall is the ladder? And it says that this one was 6. So they rounded actually to the nearest, oh, it does say to the nearest 10th. That directions, Miss Horton. So 9.2. So when you do the difference there, you have to do the 9.2 minus the 6. It's 3.2. Yes. Okay. Sorry, this thing's not wanting to write there. Sorry, that's D. Struggles real with my computer this morning. All right, so the diagram shows 3 squares that are joined together at the vertices to form a right triangle. So here's our right triangle. So this one is our hypotenuse, remember, so this is the largest area. We talked about this. So this one plus this one is equal to this. So let's look at our statements, or our choices. The sum of the areas of squares R and S is greater. Nope, they're the same. So the word greater makes this not true. B, the sum of the areas of the squares of R and S is less. Nope. The sum of the squares of R and S is equal. Yes. Okay, then obviously it's not D. All right, one more question. A right triangle and 2 of its side lengths are shown in the diagram. Which measurement is closest to the value of X? Right triangle is here, so this is C. So you're going to do 12 squared plus 8 squared is equal to C squared. This is 144 plus 64. And then you're going to add those together and then do the square root. All right, so use your calculator. You're going to add 144 plus 64. You get 208. And that is C squared. So do the square root, and we're going to round it to the nearest 10th. Should be able to just push that square root sign. Yeah, so 14.42. So rounded to the nearest 10th, it would be 14.4. Make sure you email me that this is complete. I will not check Classic until I get that email. If you have any questions, let me know.